Aloha and welcome to the screencast on WattDepot. Now, you may have heard me say before that a screencast was one of the most important things that you would learn this semester. I'm not going to say that this week. What I'm going to say this week instead is that this screencast is going to be one of the coolest things you're going to learn this semester. Okay? What we're going to be talking about is a system that supports collection, manipulation, and analysis of energy data called WattDepot. It's developed in my lab. I'm not going to say that WattDepot is the coolest thing you learn all semester, but what I will say is that learning how to manipulate energy data is a really cool thing. It's really fun and very interesting and very surprising in many ways and unintuitive when you start to learn how energy is actually produced, consumed, manipulated in our society. And so WattDepot is a means to that end that I want you guys to learn about this semester, and you may in future build your own custom databases or use some other kind of infrastructure for energy data manipulation. But I definitely think that learning about energy is a cool thing. Okay, so the reason why we built WattDepot, and it's been around maybe 3 years now, I guess we've had it. We're doing research on the way people use energy in their daily lives and how that can be influenced. And we needed a system that would enable us to collect data from lots of different types of meters, as well as many meters in general. We needed the data to be collected at sub-minute intervals, so not sub-second, but sub-minute. We wanted the ability to do what-if analyses, so we wanted to be able to build simulations where we build things that would look like power plants or look like office buildings, and we could simulate their behavioral patterns. We needed something that would run over the internet. We needed to be able to build visualizations in a variety of mechanisms, in a variety of ways with different kinds of visualization toolkits. We didn't want to be tied down to any one thing. And we also want to develop as open source, because my lab is, as you probably could guess by now, is very committed to open source as the development paradigm. So we looked around hoping that we could find somebody who'd already done it, so that we wouldn't have to do it and we could just get on with life and energy research. And we couldn't find anybody who'd built a system like what we needed, and so we said, okay, we'll go build it ourselves. And so what we have is a system whereby and in general, you start off and you have a solar panel, or you have a building with appliances that are consuming energy, or you have a wind turbine. So you have producers and consumers of energy, and hooked up to those actual objects, physical artifacts, are meters. And meters generally can record either the energy being consumed or the energy being produced, and generally the instantaneous power over time associated with that particular object. And hopefully you've looked at the introductory materials prior to this module so that you understand the difference between energy and power. If not, go back and take a look. It takes about like 30 seconds. Or there's actually a wiki page at the WattDepot site that talks about this. So, but there's lots of different meters out there. And what we wanted to do was put an abstraction layer between the actual meters and their protocols and the way you'd query them and get the data out and the rest of the system. So our architecture involves these things called WattDepot sensors, which are custom little pieces of software that are developed for each meter, each type of meter. And the sensors can be developed in any language. They could be C, they could be Java, they could be anything at all. It doesn't really matter. Okay, but it needs to be able to query this particular meter device, which is in turn connected to whatever is generating or consuming power, and then emit HTTP, okay, to one or potentially multiple WattDepot servers. Okay, and then on the other side of it, we can now have clients written again in any language that we want that can query our server via HTTP to request information about energy data, and then visualize it in whatever way you want it to. So This is our essential architecture. We wanted to not build in device dependency on either side. And yeah, I think if you look at a lot of the existing solutions, or at least at the time we were looking at them, a lot of them were kind of hardwired to a particular meter. So if you buy a meter, you get a software package that allows you to like inspect the data from that meter. But you know, it was specific to that meter, and there was no way to extract out kind of these three principal components, which is the storage, which is the server, the visualization, which is the clients, and then there's an analysis component in there as well that could be either on the client side or the server side. And then finally there's the piece of software that's actually interacting with the physical meter. So we built this architecture so that it could be very extensible. As new meters come out, we just build a little WattDepot sensor, and you know, that makes that meter able to talk the WattDepot language, and all of a sudden all your analysis capabilities and your visualization capabilities are all available to you. Similarly, you know, if someone is interested in visualization, they just go build their visualization component, and as long as they can query the server, they don't really care about, you know, what kind of meters are on the other side, because that's all of it been abstracted away. Okay, so as I kind of summarized before, these sensors, they're always specific to a particular kind of meter, and their job is to query that meter, get data on power and energy. You know, it could be like voltage and stuff like that as well, but generally power and energy are the two most important concepts, and then communicate that off to the server. You can associate a bunch of properties with the data that's collected by sensors, like geolocation data and so forth, if you want to. And then we have a variety of implementations. There is a kind of a standardized implementation called Modbus TCP for commercial energy meters, and so we implement that, and that enables us to support a whole bunch of different meters in one simple client. The server is it uses a RESTful architecture. For the most part, it's not pure REST, but it does you know, try to facilitate that style of interaction. Uses HTTP as the protocol, has an underlying database that it comes by default with embedded Derby as the backend database, but it's pluggable. We've written a MySQL database, and you know, we have interest in kind of seeing how NoSQL repositories would work with this. So that's an area where if you don't like the database that we supply, you can plug your own one in pretty easy. And kind of one of the most important kind of simplifications from the analysis side that our server provides is this idea of being able to aggregate sources and this concept of virtual sources, which you'll read about in the paper that's required reading for this module. And that, in combination with data interpolation, makes writing client-side stuff a lot simpler than it would be otherwise. So let's spend a couple minutes talking about that. The first idea is that whenever you think about meters and energy data in real-world settings, there's generally a hierarchy that you're concerned with. So for example, in any given building, you might want to know the total energy consumed by that building, or the total power load from that building at any particular point in time. But there's generally, or oftentimes, that the way that data is collected is not from just a single meter attached to that entire building, but you might have sub-metering. So you might have separate meters installed for the various floors and so forth of the building, and those kind of all get collected together just to, you know, in aggregate provide information about individual floors, individual, you know, towers in a building, or the actual building as a whole. Okay, so that's a very common kind of, you know, hierarchical organization of the data, which is very useful for understanding what's going on. The problem is that those meters are the clocks generally aren't exactly synchronized, and/or you're not collecting data from each of those meters at exactly the same point in time, leading to this problem that your data isn't really aligned exactly. Okay, so what's happening is, if you just kind of looked at it as a spreadsheet, you would see that, you know, that the data may be off by seconds or minutes or subseconds, and so it's hard to actually kind of aggregate together energy and power data in this kind of real world situation. Plus, you know, for example, if you're collecting data once every 10 minutes or once every 15 minutes, and you're interested at you know, the amount of energy that was consumed between, you know, midnight to the following midnight, well, you may not have sensor data at exactly those to points in time. So just again, it's what you want to be able to do is interpolate, and interpolation will actually solve both those problems by enabling you to both aggregate data together from multiple sources by interpolating what the data points would be at that particular point in time if you'd had one, as well as enabling you to look at intervals for which whose start and end points you don't have sensor data for. Okay, so here's a little graphic of the Saunders data, where because we can use data interpolation, or because the system automatically provides data interpolation for us, we can create these really nice graphs whereby we can add together data from multiple meters and show the composite power or composite energy that's consumed very easily without the client having to worry about it. It just happens kind of for free. Okay, on the client side, we want to build lots of different kinds of visualizations. That's part of the research, actually, is understanding what kinds of visualizations of energy data are actually useful to people, and at what points in time and under what circumstances a particular type of visualization might be useful. And so far what we found is that there's a couple different APIs that are helpful. One is the Google Visualization API, which is a JSON-based API. And so we provide that, and then for people who don't want to use Google Visualization or want to query the system in another way, then we provide a more standard XML-based RESTful API. And so we build a bunch of things, mobile clients, web-based clients, and so forth using the system. Here's a couple examples using the Google Visualization, which shows you can build gauges, you can build heat maps, and here's one that we built that's Google Maps based client, so you can kind of wander around Oahu and you can click down to see various sources or producers or consumers of energy. Go to WattDepot.googlecode.com to download it, although I'll hasten to add that for this class you don't need to actually download it directly from WattDepot.googlecode.com, because our build system is designed to download it for you. So you just type ANT using the simple application that I'll show you in a moment, and that will download the executable files for you. There is a discussion list, WattDepot users, which you may or may not find useful. You can also just query the class if you have questions. So that is the brief overview of what WattDepot is, and what I want to next do is go to the actual site itself. Okay, so here we are at WattDepot. I put it in the readings. I want you to read kind of this overview section to get a sense for what WattDepot's for. It goes over some of the information that was provided, and then on the wiki page, it's useful. Well, it might be useful to look at this physical concepts wiki page, because that talks about what power and energy is, and carbon, and so if you don't feel comfortable with that after having looked at our little 3-minute YouTube videos on it, you might want to read this. The REST API, okay, is here, and this, if you're interested in REST APIs, and you might want to take a look at it. On the other hand, we're going to supply a Java library called WattDepot Client that enables you to not have to worry about the actual REST API in this class. And if you didn't understand anything of what I just said, don't worry. It will all become clear in a few minutes. And the other page that I think you should take a look at is this page called Writing WattDepot Clients, because you are going to be writing WattDepot clients as part of your katas and the other project-based work on energy in this class. And so it's good to take a look at this to get the general vibe of it, but at the same time I've written a simple application called WattDepot SimpleAt, which I'm now showing you. And this is an application which will help you kind of bootstrap, get you started quickly doing the katas by providing a ready to run WattDepot client-based application that is conforms to our standards, passes verify, and so forth. So you can just kind of use this one as your template, do some little bit of renaming and you should be off to the races. Now, let's next go look at the actual assignment, and because that will motivate the next part of it. So here's the module, Introduction to WattDepot. Got some links to the WattDepot homepage. I really want you guys to all read this paper, okay, which is we published I don't know, 18 months ago, and it provides a very short but kind of concise introduction to the system, and that will help you, I think, get your mental model of what you should be doing. Okay, but here's the assignment. You're going to be writing a bunch of katas, as we've been doing all semester, this time for WattDepot. And the basic idea, if you see these, these set of instructions, is you're going to download the WattDepot simple app distribution from Google Code. You'll run verify on it, make sure that everything works okay in your environment, and then you'll rename it basically to WattDepot-katas-your username. And you'll start, kind of replacing the one Java file in it with a set of Java files that implement your katas. Okay, and then you can type, ant to compile. You can type ant -f verify to make sure that checkstyle and PMD and find bugs and everything is working fine on yours. And then there's these 5 katas that you'll implement that I think, once you get done, will provide kind of a sense for how you work with WattDepot data and the kinds of things that you can do. Okay, and that's going to set us up for the next phase, where we're going to actually write a web-based front end to the data that is being, well, actually the next stage is going to be a command line interface to the data being generated by the first year residence halls at UH, and then we'll go from there to a web base. So we've got a few different steps here, but I think it's going to work out really good. So going back to WattDepot simple app, what you'll need to do for this this assignment is go here, download the WattDepot simple app. When you're done, you'll go into the directory where it is, and you'll type ant -f verify, and that will download the WattDepot application for you. If you in my case have downloaded it already, so it's not doing that for me, but it'll download it for you. It'll compile the system. It'll run checkstyle, JavaDoc, checkstyle, PMD, and find bugs. And if all goes according to plan, it's going to pass and everything will be fine. Let's now kind of go into the system. Okay, and I'll start by showing you the build.xml file, which the differences from the Robocode system is essentially that I've changed the install libraries target. So now, instead of downloading the Robocode files from Ivy, I'm now downloading the WattDepot files from library, and I'm still downloading the JUnit files as before. The compile target is actually a little simpler than before, because I don't need to be copying those robot files over like I did in Robocode. But I've also implemented a new target called run, and this is kind of a really nice target to have in many cases, which is to simply, if you've got a system that you're developing that has a main program, okay, here's what the code would look like to actually run your program, and we can see how that works right here. So if I say ant run, okay, we get it to run, and it turns out that the output that this particular program generates is a listing of all the different sources at this particular server, and a line that talks about the latest energy data from a particular source, and then a line that talks about how old that data was. And it turns out that the data that we see on this line, okay, about the power being consumed by the Alima Tower in Halealoha, is only 15 seconds old. Okay, so it turns out that we're gathering data from these towers about every 10 seconds or so, 15 seconds, maybe 10 to 20 seconds. I don't quite remember exactly, but few times a minute we're getting that data, and so you can actually see that data is quite recent. Okay, and so the way that I implement that run command is right here. Okay, now if we go into the actual program, this is our simple application program. It's got a main program, and what it's going to do is it's going to read an argument, okay, from the WattDepot. It's going to read an argument from the command line, and then use that to, and that argument should be the URL of the WattDepot server, which is to be queried. Okay, so if I was doing this in the kind of the normal way, I'm going to build a jar file, and I'm going to go jar, and there's my jar, and then I could say Java -jar WattDepot simple app.jar, and I'm going to actually in this case get a very unfriendly error message saying array index out of bounds because I did not supply the argument for the server that I want to query. Okay, so let's kind of fix that, and actually the way I'm going to fix that is going to the build.xml, and I'm going to show you. Okay, so as you can notice, the Java target, the Java task supplies this internal element called arg, which enables you to specify what should appear on the command line when you run, something that has a main. When you run a Java application that has a main program, main method associated with it. In this case, what we're saying is when that main method is invoked, the first argument in the arg's parameter should be http://server.wattdepot.org:8190 WattDepot. Okay. Well, what we can do is show you quickly how that would look from if we were to build the jar file. So Java ant -f jar. So we're going to build the jar file, and then we're going to go cd build cd jar, and then we're going to say Java -jar WattDepot simple app.jar, and now we're going to provide that client. Whoops, darn. Okay, let's try this again. Copy, and then Java -jar WattDepot. There we go. Okay, but this time, just to start, let's provide a URL that doesn't actually work correctly. If we run that, what we see is that the system is going to output a line saying it couldn't find the server, and that corresponds to this particular case. We create this WattDepot client object, okay, which is our Java class, which we're going to use to communicate with the server, and we pass it the URL that indicates the location of the server on the internet, and then we use this isHealthy method to see whether or not the connection could be made. And it turns out that in this case, because we had a bogus URL, it couldn't be made. So we can do this again, except this time we're going to provide the right URL. Okay, and now you can see that we get the data being output that we want. We see that we were connected successfully to it, and in terms of the code, it means that this isHealthy method returned true, and we were able to get that first element off the command line, which is the URL. Okay? Then you can look through this and you can see that this doesn't do anything real interesting. The more interesting stuff is reserved for the katas, but it shows you that in every case what you're going to do is you're going to create a client. Okay, so WattDepot is essentially a client-server system. The server is already implemented, already running, already collecting data via sensors from the meters in the residence halls. All you're going to concern yourself with at this point is writing clients, okay, which is going to connect to a server which is already running and gather data. Okay, so maybe at some point in the future you'll set up your own servers and do some simulations or something like that. But for right now, I'm going to keep it simple. So every time you're just going to write this, build one of these client objects, pass in the URL that you've gotten from the command line, and then do various things. So for example, the first thing you can do is you can get all the sources defined on that server by calling this method, and then you can iterate through them and write stuff out about them, like their description. You can get the latest sensor data for any given source by using that particular method, and then I show you down here how we find out the latency, and that's essentially finding out the timestamp associated with a given sensor data item and then doing a little computation to see how old that timestamp actually is. Timestamps are implemented as XML Gregorian calendar objects. That makes it a little simpler to deal with passing timestamps back and forth via XML between clients and servers and unpacking them and so forth. So that's why that is, and it, there's a little bit of garbage associated with moving it back and forth and doing computations on it, but it's not too bad. Okay, so at this point I think you should be ready to go. So what you should do is read through all the materials, watch the screencast, read the paper on WattDepot, and then download this WattDepot simple app, run the verify command, make sure that it's okay, and then create a new unzip it again, create a new directory, rename everything so it's all set up, import it into Eclipse as your new project WattDepot-katas-username. If you don't name things correctly, I'm going to be taking off more and more points. Okay, the naming, the way I ask you to name your projects, the way I ask you to name your folders is very important in this class, just from a procedural perspective, because I'm getting 30 different projects. If you name them correctly, then we can import them all into Eclipse, and they're all kept separate from each other. We can look at the name and see who wrote it. Okay, so I beg of you, just follow the instructions and name things the way we're asking. Okay, and A, that shows me that you understand the instructions. That's always good, and can follow them. B, that's always good. B, it shows me that you actually know how to rename projects and set up a project with a given name. That's a useful skill. And then C, it just makes it faster for us to do the grading. If you just do it, it only takes 3 seconds. So it's not like a big overhead on your life to just name it correctly. So please take the time to do that. Everybody will be happier. Including me. Okay, so that is what I want to talk about. Get started, have fun with these katas. I think you'll enjoy them, and then we'll move on from there to an even more exciting energy-based client.